Hello everyone, this is our presentation about our GitHub project of path planning, and we are from the group 4. My name is Huang Yi Chen, and we want to introduce the path planning and its original concept first. Our project is using our A-star path planning system to build up a path planning program which can calculate the costs of different flights in different conditions. Path planning is a computational problem of finding sequence of valid configuration which can help move the object from the starting point to the destination, like the metro system in many cities, which provide many choices for people to get the place they want. So path planning is widely used in computational geometry, animation of computer, and computer gaming, etc. And this is some example of path planning in the video games. In aviation category, the path planning may be one of the most important tools to help pilot to make sure the navigation system of the aircraft is valid to preview the route of the flight. The path planning program could also notice the crowded airspace and generate a new route to avoid it. Also, it is useful for airlines to regulate the cost of each flight. Each flight could follow the guide of path planning to take advantage of the environment, for example like the jet stream and the wind area, which could increase the flying speed and reduce the fuel consumption. In A-star path planning program, it is like working on a chessboard with XY axis, and it needs to provide the coordinate of the start and the goal node. In the beginning, the program would calculate the A node around the start node and record the distance from the source and the goal separately. Then it would calculate the cost of time by add up the cost to the start and the goal nodes separately and select the node which have the lowest cost as next position to move. Since they move to the new coordinate, it will calculate the cost of surrounded node again and select the future position to move in. The process will be repeated many times until it reaches the coordinate of destination. We can get the trip time from the path planning program, and we also need to use some equation to calculate the cost of each flight. Many factors like the cost of fuel per kilogram and the fixed cost, they are related to the parameters of the aircraft. So we need to set up the aircraft model we need to use in the future. Here's the three kinds of aircraft we need to use in the future program. And the table here shows the cost specifications. And that's all of the introduction part.
Hello everyone, my name is Lam Cho Han. Here is my student ID card. Now it is my turn to introduce the task 1 for our group project. Here you can see from the picture, we need to match 3 different criteria by finding the most suitable airplane to come across the most efficient route. So basically, we can split task 1 into 2 major parts. One is the path planning and another is cost calculation. As mentioned above, we need to complete 2 steps for task 1. Here are some more details. Firstly, we need to modify the sample code so the obstacle and cost-intensive areas can be set, and hence successfully plot the path. Secondly, we should code the automatic cost calculation part for each criteria, then show the result at the end. The challenges we face are these 2. The first one is setting the plot, and the second one is that how can we tell the program to do the calculation automatically. Now we can shift the focus to the procedure. This is our graph with obstacle borders and cost-intensive area. We adjust the code in position around 300 to 330, while some linear equation knowledge have been used to set up the borders. After running the code, the time value will be shown with the path, which I will show it at the end of my presentation. Our part of cost calculation is based on this formula. We first preset the relevant value for each aircraft, and then submit the required cost value and the best time value into the formula. We then repeat the method for every criteria, and finally, we compare the different results and filter out the least value, which is the most efficient plane we are looking for. Now, this comes to our final performance. As you can see here, the path running smoothly and the planes are selected accurately. Yeah, so that is my part for introducing our project Task 1. Thank you for listening.
Hello everyone, my name is Danny Karnaikal Martin, student ID number 22097051D. Today I will be presenting on Task 2 for group number 4. First of all, we will look at the requirements we were expected to complete for Task 2. According to the instructions, we were supposed to automatically find the best jet stream area, and thereafter we had to add this optimal jet stream area into the final solution of our task. And we had to find the best flight path plan through this set optimal jet stream area. We mainly considered two factors when we were looking at finding the most efficient flight path. First, it had to be the shortest route, and second, it had to have the least time from the start till the destination. So now we will consider some of the challenges we faced as a group while we tried to attempt Task 2. One of the main challenges we faced was how to set the optimal jet stream area automatically without any manual input. And thereafter, to add this jet stream variable into our cost calculation, time cost calculation, if indeed the flight path did cross through it. And last but not least, we had to find the best flight path through the set jet stream area. Now we took some steps to solve and break down this task. First of all, we understood the requirements of the task as I have discussed in the previous two slides. Thereafter, we started the programming where we added the variables into our A-star path planning program so that if the flight path did indeed cross through there, it would have a negative effect on the total time by decreasing it by 0.05. But the key to solving it by finding automatically is to create a loop, which will set up temporary jet stream areas from the bottom of the set area till the top and calculate costs for each of these temporary jet stream areas. And thereafter, the program will automatically compare the lowest and find the minimum, and that will be the optimal jet stream area. And in the final presentation of the solution of the task, we set up the drawing as you can see in the right hand side on the GIF. We set the jet stream optimal jet stream area and the flight path through that optimal jet stream area. And we outputted the final path time for this flight path. Thank you for listening. Now I'll pass it on to my group member.
Hello everyone, my name is Lan Jainan. Here is my student ID card. Today I'll be talking about the task 3 in our project. The main goal is to create a new airline tailor-made with the highest efficiency for the situation mentioned in task 1, scenario 1. To do this, we must follow the fuel calculation formula and also follow some of the restrictions from task 1, scenario 1. This is all done to achieve a balance between the flight capacity and the operational costs. Now let's talk about some of the parameters and constraints. There are 3 constraints from task 1, scenario 1, which are the total number of passengers, the total trip time, and the maximum number of flights allowed. Another implied requirement from the total passenger count and maximum flight number implies the minimum number of flight capacity must be at least 250. Furthermore, we have also been given some new parameters that affect the cost calculation. For example, the fixed time cost may vary from 2,000 to 2,500 depending on the aircraft's capacity. The aircraft capacity also determines the type of aircraft, whether it's a twin-engine or quad-engine plane. In terms of base time cost, starting at $12 per minute every 50 passengers, it would cost an additional $2 for every 50 passengers more, topping out at a maximum of 450 passengers. Now let's talk about the basic logic behind the program of the task. At first, we have to input all the known and unknown values of the cost calculation formula, and all the relationships between the variables. Then the most important part comes down to the variable that represents the flight capacity, since it is the biggest factor that changes the overall cost. Let's say we have the flight capacity represented as X. the program will run once. The initial value of x will be set as 250, since that is the minimum capacity per flight due to our scenario restrictions. Then the calculation part of the code will keep on looping, gradually increasing the flight capacity from 250 to 450 in order to find the best capacity with the lowest overall cost. Every time a flight capacity with a lower cost comes out, it will replace the previous own value as the new x. As you can see on the screenshot of the terminal, the final result for the best aircraft would have 2 engines with a flight capacity of 300 passengers. This is the end of my part. Thank you for listening.
Thank you for the time. And I'm now going to talk about the challenge that we face in this project. Every project has its own difficulties. Apart from those technical challenges, we have encountered 4 different challenges. The first one is poor coordination. We don't know each other, in fact. So there's no leader in our group in the early stage of the project. And without a leader, we don't have any consensus, which means all of us are focusing on different things, and we did not know who is doing which task and what is his past, etc. Personality conflicts is also a main reason of poor coordination, because some are very shy and not willing to talk much to others. That makes it so difficult to cooperate with them. Some are very autocratic, so that there are no space to exchange ideas from different members. The second one is lack of motivation. Our group's supposed to be 8 people, but unfortunately, we only got 6 at last. Knowing that we may get fee right, it ruined our group productivity. We are all concerned about how we get the job done with 2 members missing. And as a result, the group mates are not motivated. And the third one is lack of clarity. We first got no clue of what is this project about and what the teacher expects from us. Knowing the goal of the works is essential, since it can improve the efficiency and also to deliver a satisfactory result. Therefore, our group mates spend so much time on getting to know about the tasks and duties in the project. This leads to the things easily done wrong, and then it is a bit hurry in the last few weeks before deadline. The last one is time management. One of the huge challenges is the availability of group mates. Everyone has diverse schedules. Both of us are super busy. We have different assignments and exams to deal with. Therefore, it's complicated to find a time outside class to discuss our projects. In addition, since our progress are much slower compared to other groups, we definitely need extra time to work on the project, so that we decided to make use of the function of GitHub and use WhatsApp to speed up our progress. Okay, let's pass time to the next one, and he will talk about how we solve the problem that I mentioned.
Hello everyone, I'm Bonjour Van Kelvin. Today I'm going to talk about how we can expect from the group tasks and of our project. First of all, we learn to have high team spirit. We have learned how to work as a team. There are lots of tasks that we need to finish before the deadline, so we break complex tasks into tasks and assign different tasks to different people. For example, we have divided EE and programming solving tasks that can achieve efficient processing. During the project, we can build good collaboration skills when we face challenges and problems. For example, we have learned how to be an active listener. We had to clarify and ask our teammates when we listen to the others' opinions. Because of the team spirit we have built, we were able to depend more on others and would pick up the task so we could get more work done. Second, learn programming skills. The project helped us become more familiar with the Python language. and we have learned how to use the task planning program. We also learned how to use GitHub to improve our programming skills and to learn from other programmers from around the world. For instance, we watch different programming video on YouTube, which is made by other programmers. Moreover, improve our communication skills through English. We use English as one of our communication language. As we are not native speaker, we can learn to be a fluent English speaker. That's it. Thank you.
In conclusion, I would like to briefly summarize all the main points that we discussed in this presentation. So first of all, we started with a brief background on what is path planning and how path planning is used in aviation. We mainly focused on the A-Star path planning program. Thereafter, we went through each of the 3 compulsory tasks individually and elaborated on what were the requirements, some of the challenges we faced when we were trying to solve these tasks, and finally, the steps we took to solve it and the final solution. Then my group member explained some of the problems and challenges we faced while working as a group. And lastly, what we had learned as working in a group project and learning this A-Star path planning program. This is our list of references for the sources we used. And finally, this is the end of our presentation. I hope that you have found it interesting and informative. Thank you everyone for listening to our presentation and have a good day.